Hello and welcome to the BESCARE YouTube channel. I am your instructor for the course Control Systems. In the series of this course, you will get to know the basic information related to automation control and how the work is done in automation industries. In this subject, we will be covering the following topics such as Introduction to Control System. This field will cover the definition, purpose and type of control system. Next, we have mathematical modeling of system. In this field, we will cover the differential equation, Laplace transform, transfer function and block diagrams. Next, we have feedback control system. This field will be comprises of closed loop system, feedback control, stability analysis, and performance specification. Next, we have control system design. In this field, we will cover controller types like PID control. We will cover root locus analysis and frequency response analysis. Next, we have sensors and actuator field. This will cover type of sensors and actuators, signal conditioning, and interfacing with control systems. Next, we have control system analysis. This field will comprises of time response analysis, frequency response analysis, and stability margins. Next, we have state space analysis and control. This field will cover state variables, state feedback control, and controllability. Next, we have digital control system. This field will comprises of sampling, Z-transform, digital controller design, and state space representation. Lastly, we have two major points: nonlinear control system and robust control system. These fields will cover nonlinear system analysis and uncertainty and disturbance rejection in the systems. Let me explain you what is automatic control. Automatic control is the use of control systems and feedback loop to adjust and manipulate physical processes or systems automatically without human intervention. Through the following figure, I will explain you the automatic control in more easy ways. In this figure, we have a temperature measurement device known as a thermometer. A thermometer is installed in the vessel to measure the temperature of the water. Next, we have control valves. The controller regulates the flow of cold water to the vessel through a control valve. The control valve is actuated by an actuator to open and close according to the controller's instruction. We have steam inlet, which is controlled by a solenoid valve. Further, we have a steam trap set. This steam trap set is installed at the outlet of the coil heat exchanger to remove any condensate that form in the system. We have a heat exchanger. The heat exchanger transfers heat from the steam to the water in the vessel. We have hot water outlet. The hot water outlet is controlled by a valve that is actuated by the controller. What is control system? A control system is a system that is designed to regulate, command, or manage the behavior of other systems or processes. Control system is classified as open loop control system, closed loop control system, linear control system, non-linear control system, and time dependent control system. We can further classify time-dependent control system as time-dependent control system and time-independent control system. First of all, you will see the figure of the open loop control system. In open loop control system, there is no feedback loop. Whatever the output, it will not depend on the input supplied to the controller. Now you can see the figure of the closed loop control system. In closed loop control system, you can see there is a feedback signal. This is a time-dependent control system. In the time-dependent control system, as we said earlier, that we can classify them into two more classes as the time-variant control system and time-invariant control system. In time-variant control system, the output will depend upon the time, while in time-invariant control system, the output will not depend upon the time. We have linear control system. In linear control system, the output and the input have a linear relationship between them. Furthermore, we have non-linear control systems. In non-linear control system, there is not a linear relationship between the input and output. Therefore, there is a non-linear relationship between them. Now there are some pros of open loop control systems as well as the cons of the open loop control system. First of all, we will start with the pros. The open loop control system, as there is no feedback loop, it is simple to operate. They are cost effective. They are well for the systems having little or no uncertainty. Moving on towards the cons of open loop control system. They are susceptible to disturbances as they do not behave well in the presence of disturbances. There is lack of accuracy as there is no feedback control loop between input and output. They are not adaptable to the changes. Now we have pros and cons of closed loop control system. Closed loop control systems are accurate and adaptable to the changes as there is a feedback loop between the output and the input. They are reliable and they are stable too. Now the cons of the closed loop control systems are they are slow, they are costly, and they are complex because of presence of a feedback control system. I believe that everyone can learn and benefit from understanding the principle of electrical engineering, and I'm excited to share my expertise with you. So if you find this video a little bit informative, so please subscribe to the channel, hit the notification bell and join us to this journey to explore the fascinating world of industrial control system. Thank you very much.